Hi everyone. In this video we will be talking about implicit type problems. So in the last video we discussed logarithmic type problems, which is basically a special type of differentiation problems. In this part we will talk about implicit type problems. So what are implicit functions? I mean, in case you don't know, implicit functions are functions in which you cannot separate y and x. So basically that y and x have a relation, but they cannot be separated such that y is a function of x. It's basically a relation in which you cannot separate x and y. So you might be asked to find derivatives of those functions, and naturally the derivative of those functions of dy by dx will come as a function of both x and y, but there might be problems on that. So to solve that, I basically wanted to give you an example in this part of the video. So let us start with an example of implicit type problems, and in this again you will use the knowledge that we have already basically of the videos which we have already discussed. So the problem is, find a derivative. So a relation has been given, x raised to the power of sine y is equal to y raised to the power of sine x, and we have been asked to find what is dy by dx. So till now we have always been doing problems where y was a function of x. Here y has some relationship with x, but we cannot just directly write y as a function of x. It is implicitly defined. There is a relation which has been defined, and we cannot directly find y as a function of x. So what do? So we'll just treat it like a normal problem, but whenever we are differentiating anything related to y, we'll first differentiate it with related to y, and then we'll write dy by dx using chain rule. So that is the idea behind implicit type problem questions. So let us do it hands on, and then we'll probably get to you'll realize what I'm trying to say. Okay, so now how do I solve a problem where x raised to the power of sine y is equal to y raised to the power of sine x? This has been covered in the logarithmic type problems video, in which basically you can see that both exponent and coefficient are a function of x. So y is a function of x, and here y is a function of x, and the power is also a function of x. So when both of them are a function of x, what do? We take log. That is the only thing you can do, and that will make life much easier. So take log. This is a logarithmic type problem, so let's take log. So when we take log, this will be sine y log x is sine x log y. And now, as we had done in the last video, now we will differentiate. So when we differentiate here, these are two things, so we will use product rule. So again you have to remember all the things which you have discussed in product rule, sum rule, chain rule. So now differentiate sine y. So sine y, you will first differentiate with respect to y, because there is something in the sine which is not x, so we will differentiate with respect to y. So this will be cos y, and then you will differentiate y with respect to x, like we used to do in chain rule. So this is dy by dx. So this is how the implicit portion comes in, and you will then multiply by log x plus derivative of log x multiplied by sine y, plus sine y, and derivative of log x is nothing but 1 by x. Now you have to add derivative of sine x into log y, which is cos x into log y, plus derivative of log y. So again we will use chain rule. So let's just differentiate first with respect to y. So log y is nothing but 1 by y, and then differentiate y with respect to x. So this will become dy by dx. So you can then club dy by dx terms together, which means that this would be cos x log y, cos y log x minus 1 by y is equal to cos x log y minus I think here there will also be sine x, because I have differentiated with respect to y and multiplied by sine x. So sorry, here there will also be sine x. So I hope it was clear. I just missed. So when you differentiate the second term, you will also have to multiply the first term. So there was a sine x here, and hence this sine x will come here also. So the cos x log y minus sine y by x. Alright. So now you will get dy by dx as cos x log y minus sine y by x by cos y log x minus sin x by y. So this is how you'll get dy by dx. So whenever you see something, an implicit relation with respect to y, y and x, all you need to do is just treat y as a function of x and then add dy by dx when you're differentiating with respect to x. And at the end, the final answer has both x and y. That is natural because it is an implicit function. And also in this problem, we saw another problem of logarithmic type. So again, remembering problems in types really helps. In the next video, we will talk about more types of problems. So I hope you liked the video, and check out the next video for more types of problems in differentiation 1. Thank you.